Examples that I did with second period started with number 1, so it would still benefit you if you have a hard time with the problems to go back and look at the other video because it's other problems. Okay, so for those of you who were able to watch the video, we have a fraction, and a whole number. What do we do with the problems that have a whole number? For anyone who was able to watch the video. We put it over 1, we want to turn it into a fraction. So if we have a complex fraction, that just means that it's made up of multiple fractions, and we want to make sure in a complex fraction that every single piece is currently written as a fraction. So I'm going to take the 5 and I'm going to put it over 1 because I want every single part of the complex fraction to be written as a fraction. So now this is a fraction, this is a fraction, and this is a fraction. And now I'm going to look at all 3 of the fractions that I have, the 5 over 1, the x squared over 5, and the 5 minus x over 3x. I'm going to look at all 3 of those fractions, and I want to find the common denominator between all 3 of them. So I've got a denominator of 1, a denominator of 5, and a denominator of 3x. So 15, between the 5 and the 3, 15. And then what else would I need for my common denominator? X. So my common denominator is going to be 15x. Okay? And then whatever the common denominator is, we're going to multiply by that on the top and the bottom of the fraction. So 15, and I didn't really leave myself enough space, so I'm going to erase this and just move it over. Common denominator is 15x. I'm going to multiply by 15x over 15x. So if I multiply by the same thing on the top and the bottom, it's kind of like multiplying by 1. Like multiplying by 2 over 2 or 5 over 5 or negative 3 over negative 3. If you multiply by the same thing over the same thing, it's like multiplying by 1. So it's going to change the way my expression looks, but it's not going to change what the expression represents. It's still going to represent the same thing, it's just going to look different. So now I'm going to take the 15x on the top and I'm going to multiply it by each of the 2 fractions on the top. And I'm going to take the expression over here on the bottom and I'm going to multiply it by the fraction on the bottom. So I've got 5 over 1 is being multiplied by 15x minus x squared over 5 is being multiplied by 15x, and then 5 minus x over 3x is being multiplied by 15x. So, does anyone know what 15 times 5 is? 75? Okay, so we got 75x. All right, minus. Over here we have divided by 5 and multiplied by 15. So if we reduce those, what happens? Yeah, we got 3. So take 5 out here, take 5 out here, that becomes a 3. So I have an x squared being multiplied by a 3x. X squared multiplied by a 3x. 3x cubed. Okay? So that's all I have left over on the top. And then on the bottom, I have a 3x and a 15x, so I can cancel out the x's. Are you guys okay with that? And then what about the 3 and the 15? What would happen there? Yeah, divide by 3 and you get 1 on the bottom. Divide by 3 here and you get 5. And so I'm going to take the 5 out here and distribute inside. So 25 minus 5x. Are we comfortable with all of the steps so far? What part was weird?
What point can you start at?
What part can we what? So what I did is I had my common denominator and I wrote it next to each of the terms, and it was the common denominator that I was canceling with the denominators. So I had the common denominator here. Yep. Now, on the very first day of the unit, we said we take the fractions, we make sure we always write them as numerator over denominator, right? And then the second thing we had to do is we always had to write them in the correct order. So for this problem, both the top and the bottom are written in the wrong order. So how should we fix the top? Okay, perfect. So negative 3x cubed plus 75x. So now the top is in the correct order. The bottom should be negative 5x plus 25. Okay? So we got that, and now we are ready to factor. So what type of factoring do you guys see on the top and bottom? The same type, GCF. So what's the GCF on the top? Negative 3 and an x. Okay, so negative 3x. And what does it leave behind? X squared minus 25, okay? And when you guys see the x squared minus 25, what does that make you think of? Perfect square. And what type of factoring do we have that uses perfect squares? Yeah, it's the difference of squares factoring, right? X plus 5x minus 5 is what the top is going to become. So I'm going to come down here. I'm still writing the top. Negative 3x, x plus 5, x minus 5. Okay, so we're still on the top. Okay. On the bottom, we can take a GCF out. Negative 5. Okay. That leaves x, and then what else does it leave? Minus 5. Okay, and I'm just going to go ahead and copy this down. All right, and then what do you guys see that could cancel? X minus 5. And one more thing, actually. The negatives. Yeah, the negatives can cancel and just make the whole thing positive. Okay, so on the top we have a 3x left over and an x plus 5 left over and a 5 on the bottom. Can the 5s cancel? No, because one is in parentheses, one is not. This is actually answer choice D. You can see it matches up perfectly. You guys, the punchline on this one is real good, if I do say so myself. All right. Let's go to number 14. So if we look at number 14, we have all of these are written as fractions. So we don't have to fix any of them to become a fraction because they're all already there. We have a 4, we have an x, and we have a 2x. So what's the common denominator going to be? 4x and 2x. You could use 8, but you don't even need to use 8. You could do something smaller. 4. You can do 4. And what else? X. We need an x. Okay? So we're going to multiply by 4x over 4x. And the 4x on the top is going to multiply by the two fractions on the top. And the 4x on the bottom is going to multiply by the fraction on the bottom. So I'm just taking that common denominator and I'm basically writing it next to each fraction. I've multiplied it by each fraction. Is there any confusion so far? We're good? Okay. So if we look at the first fraction, what can cancel or what could reduce? The 4s. Okay, so we have an x left over and the x needs to multiply. And when it multiplies, what does it give us? X squared minus 4x, okay? In the second fraction, the x's are going to cancel. So we get 4x minus 16. Well, we got to do the bottom. On the top, we stopped, yeah. So we had to do, the 4's canceled, and we had to distribute the x's. Or just the x, and then over here the x's canceled, and we had to distribute the 4. The x minus 4's had to come down, yeah. And then down here, we can see the x's are going to cancel, right? What about the 4 and the 2? It's going to simplify, right? It's going to reduce. So it's going to be a 2. And then I'm going to take the 2 and I'm going to multiply it. 2x minus 8. Okay. So what do you guys see on the top? Yeah, the 4x's cancel each other out, and we get x squared minus 16, and that should make us think of something, right? Yeah, that's difference of squares. That gives us x plus 4, x minus 4. Okay, so on the top, x plus 4, x minus 4. And then what do we have on the bottom? Okay, on the bottom we take out a GCF of 2, and we have x minus 4. And then the x minus 4's cancel. Was everybody comfortable at this step? We saw the difference of squares. We saw the GCF. We can see those parts, okay? And then we got x minus 4, those go away. X plus 4 over 2. Done. So what answer choice is that? N. Okay. So we're running out of class time, but the other video that I posted up there, it's got 1, 2, 3, and the start of 11. So if you need to see more of the worksheet problems, 1, 2, 3, and the start of 11 are on the other video if you need them. Okay?